Hello, and welcome back to another episode of Low Spec Labs. Before we get started, I would like to stop and say thank you to everybody who has commented, thank you to everybody who has subscribed, and thank you to everybody who has hit the like button. If you would like to continue consuming this content, go ahead and hit subscribe either here on TikTok or on YouTube. Otherwise, let's get started. But hold on, one more thing before we go. Let me write this out. Thank you so much. Oh yeah, hopefully you can read that. So the first question we have to ask is, how does a Linux server boot? The answer to that question is pretty straightforward. We use Grub, which we've talked about before, and we use systemd, which we've also talked about before. Let's go ahead and talk about systemd first. That's kind of the easier of the two since we've already gone over it before. What? If you don't know what systemd is, that's okay. If you go to my YouTube channel, there's a video called RHCSA Chapter 11, Working with systemd, where I go into the subject for about 30 to 45 minutes. It is very detailed. It even includes labs. Lots of good information there if you feel like what I'm about to cover is too brief or assumes that you know too much. You're probably thinking, how is systemd related to booting? Well, systemd controls one of the 4 primary states your Linux server can boot into. What are these primary states? These states, or targets, are the 4 modes your server can be in, more or less. We should probably loop back around and ask ourselves, what is a target? So recall, a target is a unit file. So this is our file, and inside of our file are the define settings, right? And what it does is define settings that point to a folder, right? So this is our folder, and inside of this folder is a bunch of other unit files. And remember, a unit file is basically just a file that defines services that start automatically. So a target is a file that automatically starts a bunch of unit files, aka services. So targets start a bunch of services at the same time. Now let's talk about the 4 different targets your Linux server will start in and what different modes do. The first state is emergency.target. What do you think it's used for? Here's a hint: emergency mode. I know, right? I was surprised by that. Yeah, just like its name implies, emergency.target or emergency mode is a minimal version of the Linux kernel, booted up with the bare minimum number of services needed to run the Linux system. Normally you're booting into this mode to reset your password or to fix your kernel. The second mode is rescue mode. What is rescue mode? I'll give you a few seconds. Basically, it starts your system up with a few more services than emergency mode. Technically, it's all the services your system would be running if it was a fresh bare install with no additional anything installed on it. So that's somewhat useful. The third mode is multi-user.target. This is technically the default target. So if you were to install a Linux server without a graphical user interface where you just kind of see like the command line and the console, that is multi-user.target. That is your standard, things are working just as they should operating level. And the last mode is graphical.target. So if you have a graphical user interface installed, something like XFCE, KDE, GNOME, you would be booting into graphical.target. What is a Linux want? Well, just like the word want in English, a Linux want is stuff your targets will want to be running on the server before they start. Wants are systemctl dependencies, more or less. So just like you need dependencies to run certain software on Linux, like you might need Python 3 to run an application like HTOP, Wants are dependencies for your unit files. So in order for the unit file or target file to work, all these other unit files have to be included as well. So we know what wants are, we know what units and targets are. How do we enable a unit file? If you recall, that command is systemctl enable. What happens when you run systemctl enable? So systemctl enable creates a symbolic link, otherwise known as a shortcut. Once the shortcut is created, it's created inside of etc systemd system, and then whatever that target folder is .wants. And inside of that .wants folder are going to be the unit files that your target needs in order to start. All right, so that is a lot of theory that we've already gone over all the way back in chapter 11. You should roll the tape back and take another look. We have gone over a lot of theory, ladies and gentlemen. That was only 5 minutes. Can you believe it? It was not 5 minutes to me. Obviously, it was much longer than that, but to you, it's only been 5 minutes. I hope you're enjoying the content, because I know I'm enjoying my time making it. When it comes to managing the Linux boot process, basically there's two applications you're gonna have to manage. Those two are Grub and Systemctl. Now that we know what units, wants, and targets are, let's talk about managing your systemctl targets. Earlier in this video, I said there were 4 systemctl targets. Let's go over those 4 targets real quick. The first systemctl target your system boots into is emergency mode. Emergency mode is the kernel launching and mounting the file system in read-only mode. It's basically for emergencies to get data off your server if it's completely foobarred. The second systemctl target that your Linux system will boot into is rescue mode. And just like the name implies, rescue mode is going to help you rescue your system. So rescue mode lets you start the file system in a read-write format, so you're actually able to modify it, and that's useful for doing stuff like changing your password in case you forget it. Another thing rescue mode lets you do is use some system utilities. So unlike emergency mode, you do actually have programs that you can access in rescue mode to make changes. The second systemctl target that your Linux system will boot into is rescue mode. And just like the name implies, rescue mode is going to help you rescue your system. So rescue mode lets you start the file system in a read-write format, so you're actually able to modify it, and that's useful for doing stuff like changing your password in case you forget it. Another thing rescue mode lets you do is use some system utilities. So unlike emergency mode, you do actually have programs that you can access in rescue mode to make changes. Did you know you could isolate systemctl targets? Basically, that means you can force the Linux server to boot into a specific target. So for instance, if you had a server that you wanted to be the third systemctl target that you can boot into, number 3, and the one most Linux servers boot into, is multi-user.target. So this is basically a mode where you get access to your console. So you get access to the command line, but nothing else. And last but not least, there is the 4th target, and that is graphical.target. And that's for your GUI applications. So in order to view your GUI applications, you're going to need number 4, graphical.target up and running. So for instance, let's say we had a server that we installed and it was a console only server. Well, that would mean it only boots to multi-user.target. If we were to then go ahead and install X server, so we have GUI applications, we would need to switch to multi-user.target. And to switch to multi-user.target, we would isolate that target. So target isolation is basically just forcing your system to boot into one of the target modes. Let's go ahead and do systemctl isolate rescue.target. And there we go. We have now entered rescue mode. It's as simple as that, right? And as you can see in rescue mode, we have to give the root password, and then we are in. And then from here, we can do stuff like change the password, back up our files, do whatever we have to do to get this system fixed. And then afterwards, we just reboot. We can also use the systemctl isolate command to reboot our host. So if we were to do systemctl isolate reboot.target, it's going to ask us for our password, and there we go. Our system's going to reboot, no problem. Okay guys, would you believe me if I told you I'd been sitting at this reboot screen for like 5 minutes wondering why this system wouldn't boot up when I literally put it into a infinite reboot mode with that systemctl isolate command. So with that command, I just told this system to reboot, and then it looked, after it reboots, it looks and says, oh, I should be in reboot mode, and then it reboots again, and then looks and says, oh, I should be in reboot mode. So we've basically infinite looped this VM. We're gonna have to close it down. Hopefully a reset is all we need to do. Worst case, we'll learn how to change our grub boot options, but hopefully not. Oh, something's happening. Cross your fingers. There we go. All right, and that's it. What if I want to isolate a systemctl target? Let's do capture. So we'll do systemctl get default, and that default is graphical.target. What if we want to set the default systemctl target? We do systemctl get default, and then we do systemctl set default. See how easy that is? And then the default we're going to set is multi-user.target. Then of course we're going to enter our password. There we go. Have to spell it right with the hyphen, and there we go. Our new default is multi-user.target. So when we reboot, it should reboot to the console mode and allow us to type in commands there rather than GUI. So let's give it a second here. It's booting in the grub, and we are at our console, which is just the text-based interface. So we've talked about systemctl. Let's talk about Grub 2. So Grub is the bootloader, and Grub 2 is the latest version of Grub. It's been around for like 20 or 30 years, so they update it pretty consistently. I went ahead and rebooted my test server, and we now have Grub loaded up. So when you first start your Linux server, you'll see this screen, and what this screen does, it lets you either select the kernel you want to boot from, select the Linux version or operating system you want to boot from, or it allows you to edit the boot options you're using. Remember, Grub is installed on the boot sector of your hard drive, and Grub is used to load the kernel. Grub also loads the init RAM FS, which is basically where your drivers for the operating system live. We can also use Grub to boot directly into our systemctl targets. So for instance, if we had a broken system, we could start Grub, and then we could hit E for edit. Then what we want to do is go to the very end of this line right here. So let's go back one, right where it says Linux. Do you see this line that starts with Linux right here? We go there, and then what we can do is just add a simple line of text to the end, like systemd.unit. So we can do systemd.unit equals rescue.target. All right, so we then hit Control X to boot, and it should boot us directly into rescue.target since we now have that line added to the end. And with that, we're now booted into rescue.target. Modifying Grub at the bootloader is one way to edit your boot options. Another way is to boot into the actual system and edit your Grub config file. That config file is located at etc default grub. Very convenient naming convention there. So we now have our system booted back up. Let's look at that Grub config file. If we were to do a cat/etc default grub, you can see the output of Grub right there. And then if we were to do a nano/etc, oh, this is going to be a sudo, etc default grub, and we enter the password, and there we go. We now have Grub pulled up. So inside of this Grub config file, we can set some default Grub settings, right? So we can do stuff like turn the graphics icon off, change the color, change the output of the terminal, right? Change the command line right here to change how the system boots. So for instance, if we were to do systemctl.unit equals rescue.target and then reboot our server, it would automatically reboot into rescue.target every single time.